Hi everyone, it's Rohan this side, and in this video, I'm going to solve the entire S1 paper that came in Cambridge in the October-November 2024 session. Subject code is 9709, paper is 5, and the variant is 2. Now, I have given timestamps in the description. You can access these timestamps to go to any question in which you are having doubts, and you can get the step-by-step solution over there. Or if you are new to paper solving, then obviously you can watch the entire video. And in case if you're having any doubts, you can leave them in the comment section below. But let's say if you want to reach out to me and solve your doubts with respect to mathematics or physics, I'm going to leave the different WhatsApp group links in the description as well. You can check that out. And if you are having a query of how you can join in my live online batches, then you can directly DM me on the WhatsApp on this number. And let's say, for example, if you want access of this whole PDF, I'll be leaving that as well in the description. So don't forget to check out the description of this video. So let's get started with our first question. At a college, the students choose exactly one of tennis, hockey, or netball to play. Now the table shows the number of students in year 1 and year 2 at the college playing each of these sports. And the way that you should read the table is, let's say for example, there are 16 students from year 1 playing tennis. There are 18 students from year 2 playing hockey, so on and so forth. You can read the entire table. Now, one student is chosen at random from the total of the 120 students. So if you count this, the total will come out to be 120. So we are choosing one student at a random from this total of 120 students. Now event X is that the student is in year 1 and event N is that the student plays netball. In the first part, we are asked to find the probability that the student is in year 1 given that the student plays netball. So this is a basic question that we are having from the conditional probability. You can directly do this from the table itself. So it's going to become that the student is from the year 1 and plays the netball. From the total people playing the netball, which is 40, 12 plus 28 is 40. So 12 by 40 will be straight away the answer. But let's say if you are not someone who is good with reading the tables and getting the answers for the conditional probability, you can also go ahead and use the conditional probability formula itself. So whenever you are having probability of x given n, the equation will be probability of x and n divided by probability of the given thing. So if I solve this, what is the probability that student is in year 1 and plays the netball? So there are 12 such students out of 120. So 12 by 120 is the probability divided by what is the probability that student plays the netball. So 12 plus 28 is 40. So out of 120, there are 40 students playing the netball. So 120 and 120 gets cancelled out and you are left with 12 by 40 being the answer. So you can directly do this from the table that there are 12 students in year 1 that plays the netball out of 40 students who plays the netball. So 12 by 40 right away you could have got it, or else you can use this full formula as well. It is completely your choice. So the answer comes out to be 12 by 40. And just like this, if I have to solve the second part, find the probability that the student plays the netball given that student is coming from year 1. So again 12, but this time it's coming from year 1. So if you do the total of 16 plus 22 plus 12, for that I'll just take out my calci. 16 plus 22 plus 12, that comes out to be 50. So there are 50 students total in year 1, out of which 12 plays uh, the netball, and therefore the answer will be 12 by 50. Or else you can also use the whole formula, probability of n given x. So probability of n and x will be exactly the same like what we had earlier, but now the probability of x will be the total students in year 1, that are 50 by 120. So the top part remains the same. N and x will be 12 by 120 divided by probability of x is 50 by 120, and therefore 120 gets out and you are left with 12 by 50. And therefore, I can say that the answer for the second part, probability of n given x, will be 12 by 50. Now for part C, we are asked to find or determine whether or not x and n are the independent events. So if probability of x and n is equal to the probability of x into probability of n, then x and n are independent events. Independent events. Or else they are dependent events. So for this, what I'll do is I'll calculate what is the probability of x and n. I already know it's going to be 12 by 120. Similarly, I'll calculate what is the probability of, I'll choose a different color now. What is the probability of x, and then what is the probability of n? I've also calculated this. The probability of x is 50 by 120 and the probability of n is 40 by 120. And what does this indicate? This indicates that probability of x and n, which is coming out to be 12 by 120 is 1 by 10, and then probability of x into probability of n will be, if I take out my calci, 5, or sorry, I should say 50 into 40 by 120 into 120, it comes out to be 5 by 36. So as both of them are not equal, what can we say? We can say that therefore x and n are not independent. We can say that they are dependent events. Dependent events. Or you can also say are not independent events. Now, for the part D, first of all, we need to read the above statement. It states that one of the students who plays netball takes 8 shots at a goal. One, or I should say, on each shot, the probability that she will succeed is 0.15, independently of all the other shots. We have to find the probability that she succeeds on fewer than 3 of these shots. So if you notice, this question can be converted into a binomial distribution because we are having that there are fixed number of trials, then there are only two possibilities, either success or failure, and then the probability of success always remains constant. And we can also count this kind of discrete random variable, that is the number of shots taken at the goal. We can count it like 1 2 3 4 5 6 7 8. So based on this, I can say that, let's say for example, let x be that random variable or the discrete random variable, which is the shots taken at the goal by student. And we can say that x follows binomial distribution with the fixed number of trials are 8 and the probability of success of getting the goal is 0.15. And based on this, I can say that we have to find probability of x less than 3, which means probability of x is equal to 0, 1 and 2. And according to the formula of binomial distribution, it is going to become NC, so 8C0 into P to the power of 0, so P is 0.15 to the power of 0 times Q, which is the probability of failure. So 1 minus 0.15 is 0.85. So 0.85 to the power of n minus r. So 8 minus 0 will be 8 plus 8C1 0.15 to the power of 1 into 0.85 to the power of 8 minus 1, which is 7. And lastly, 8C2 0.5 power of 2 and 0.85 to the power of 6. So one power increases and the other power decreases. And now if you want to solve this in CAIE very quickly, what you can do is you just open your CAIE and press the summation symbol and just mention 8. I'll mention this in the bracket 8C and then alphabet X. Then multiply this with the probability of success 0.15 to the power of X alphabet X into the probability of failure, which is 0.85 to the power of 8 minus X. And then X is going to go from 0 to 2. And then if you equate this, it will be the same thing as compared to what you would do this calculation that is written on the board. And it comes out to be 0.895 correct to 3 decimal places. 0.895 correct to 3 decimal place or 3 significant figures as well. And that becomes our final answer. Now let's move on to question 2. In the first part, we are asked to find the number of different arrangements of the 9 letters in the word algebraic. So if you can notice, A is coming twice. Apart from that, L, G, E, B, R, I, and C are coming exactly once. So based on this, I can say that because there are 9 places in which I can arrange this, the total possibility of arranging them is 9 factorial ways. But then, because A is coming twice, I'll also need to divide this by 2 factorial, and that will be the total number of different arrangements of this 9-letter word algebraic in which A is coming twice. So if I just open my CAIE and solve this, it is 9 factorial divided by 2 factorial, and that comes out to be 181440. 181440, and that becomes the final answer of part A. Then in part B, we are given find the number of different arrangements of this 9-letter in the word algebraic in which there are no more than 2 letters between two A's. In which there are no more than 2 letters between two A's. So there could be 0 letters between the A, or there could be 1 letter between the A, or 2 letters between the A's. So based on this, what are the different arrangements of this algebraic word or the letters inside the algebraic word? So the first scenario is when both of the A's are together as a single block. A must be together. So if I remove 2 out of the 9 letters, I am remaining with 7 other letters. So 1, 2, 3, 4, 5, 6, 7. So there are total of 1, 2, 3, 4, 5, 6, 7, 8 different places in which I can arrange these two A's together. And therefore, this will become 8 factorial. Now for the second possibility in which I can have one letter between two A's, it will be something like this. A dash A. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So for this, first of all, let's see in how many ways we can have A arranged over here, such that there is one empty space between that can be filled by any other letter. So this is my one possibility in which I am having one empty space in between. The other possibility could be that I am having A over here and then an empty space in between and A over here. So that is my second possibility. Then this is my third, fourth, fifth, sixth, and seventh. So there are 7 different possibilities in which I can have my A's over here. So 7 for that. And then Apart from A, there are 1, 2, 3, 4, 5, 6, 7. 7 different letters that I'll need to arrange. So that can be done in the 7 factorial ways, and none of the letters are repeated, so I don't need to divide this by anything. And in the third scenario, I am having A and then 2 letters in between, and then again A. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So first of all, in how many different arrangements I can have my A such that there are 2 letters in between them. So that's my one possibility. Then this is my second possibility. Then this is my third possibility. Then this is my fourth. This is my fifth. And this is my sixth. So there are 6 different ways to arrange A. And then because again there are 7 other letters that I can arrange and none of them are repeated, so 7 factorial will be multiplied with it. And therefore total ways to arrange this will come out to be 8 factorial plus 7 into 7 factorial plus 6 into 7 factorial. And if I do this in my calci, 8 fact plus 7 into 7 fact plus 6 into 7 factorial, then this comes out to be 105,840. 105,840, and that becomes the final answer. Now for question 3, a fair coin and an ordinary fair 6-sided dice are thrown at the same time. The random variable x is defined as follows. If the coin shows a tail, x is twice the score that is present on the dice. If the coin shows a head, then x is the score on the dice if the score is even, or else x is 0 everywhere else. So I can just draw a quick probability space diagram. So it's going to be something like this, where my score on the dice could be 1, 2, 3, 4, 5, 6. And on the coin, I can have a head or a tail. So if the coin shows head, for the even number, the score is as it is. For everywhere else, x is 0. So 0, 0, 0 because they are not even 1, 3 and 5. And for 2, 4, 6, it's going to be exactly as it is 2, 4 and 6. And for the tail, the value of x is twice the score on the dice. So 1 into 2 is 2, 2 into 2 is 4, 2 into 3 is 6, then 8, 10 and 12. So these are the possible values of the x: 0, 2, 4, 6, 8, 10 and 12. And based on this, we're going to draw up the probability distribution table for the x. And the way that I can do this is I can write x on the top, and then I can write the probability of x equaling x in the second row. And on the top, the possibilities are from 0 to 12 in the even numbers: 0, 2, 4, 6, 8, 10 and 12. And then I can just complete the table. That is how it's going to look like. And if you want, you can also draw a line over here. Now, what is the probability of 0 coming on this probability space diagram, or the possibility space diagram is what we rather call it. And for this, I'll be using red color to fill it up. In total, there are 1, 2, 3, 4, 5, 6 into 2, 12. There are 12 different outcomes. Out of 12, how many times 0 is appearing? So 0 is appearing 3 out of 12, so that will be the probability. Then 2 is appearing 2 out of 12, so that will be the probability. For 4, it is again 2 over 12. 6 is appearing only once, 8 is also appearing only once, 10 and 12 is also appearing only once. So 1 by 12, 6 is appearing twice, my bad, over here and over here, right? Then 1 by 12, 1 by 12 and 1 by 12. We can also confirm this if it's correct or not. If sum of all the probabilities add up to 1, we are good to go. So 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 1 is 10, 10 plus 2 is 12, and 12 by 12 is equal to 1. It means that our probability distribution table must be correct. That is how you solve your first part. Now, in the second part, we are asked to find the variance of this x. And the way that we do this is, we take the square of x and multiply it with the value of the probability, then add it with all the remaining values of x and the respective probabilities. So 0 square into 3 by 12 plus 2 square into 2 by 12 plus 4 square into 2 by 12, so on and so forth until we are done with the entirety of the table. And the way that we're going to do this over here is, let me choose a blue color. So variance of x will be summation of the value of xi into pi, where I starts from the first till the last value, minus the mean of x bar square. And what is the mean? Mean is simply multiplication of x and the respective probability and summation of all of this. So based on this, we are going to get 0 square into 3 by 12. I don't need to write it. Then I have 2 square into 2 by 12. Then I'm having 4 square into 2 by 12 plus 6 square into 2 by 12 plus 8 square into 1 by 12 plus 10 square into 1 by 12, and lastly 11 square into 1 by 12. And if I substitute this in my CAIE, let's see what do we get. So I am having 2 square into 2 by 12 plus 4 square into 2 by 12 plus 6 square into 2 by 12 plus 8 square into 1 by 12. I can also take 2 by 12 and 1 by 12 as common, but I realized a bit later, but never mind. Let me complete it. Okay, it's not 9 square, but 10 square. So 10 square into 1 by 12. And then, okay, I did one more mistake. It must be 12 square over here, right? Not 11 square. But yeah, let's continue this. 12 square into 1 by 12. So this comes out to be 35. Okay. Now minus the square of the mean. So let's calculate the mean for that. So it's going to become 0 into 3 by 12 plus 2 into 2 by 12. So I'll just do it like this. Okay, 2 by 12 is common, and then I just need to have 2 plus 4 plus 6, 2 plus 4 plus 6, and just like this I'm having 1 by 12 as common for 8, 10 and 12. So 8, 10 and 12, and then it's coming out to be 9 by 2. So 9 by 2 whole square. And therefore, based on this, let's see what is the final value of the variance that we're going to get. So in my CAIE, I'll be writing 35 minus answer square. So it comes out to be 59 by 4 or 14.75. So 14.75 is what I can write. So that becomes our final answer. And now let's move on to question number 4. It is given that the heights in meters of white pine trees are normally distributed with the mean of 19.8 and the standard deviation of 2.4. Now in certain forests, there are 450 white pine trees. In the first part, we are asked to find how many of these white pine trees would you expect to have the height less than 18.2 meters. So as you can see that the question is coming from the normal distribution. And to find the expected value, what I'll do is I'll find the probability of the randomly selected white pine tree to have a height less than 18.2 meters. Based on that probability, I'll multiply that with the 450 value to get the expected value. It is n into p. And therefore the value of n is 450, and the value of the probability for this randomly selected white pine tree to have a height less than 18.2 meters, I'll be getting it with the help of normal distribution. So for this, I'll have a random variable that I'll be defining for my x. It is the height of randomly selected white pine tree in meters. And then this x belongs to the normal distribution, that the mean is 19.8, that's the mean height, and the standard deviation or the variance, that is what I need to write in the definition of the normal distribution, will be 2.4 square. 2.4 is the standard deviation, the square of that is the variance. And now the first step is to find the probability of this x having the height less than 18.2 meters. And because we are dealing with the normal distribution, I can easily convert this into the standardization using the z-score. So probability of z less than 18.2, that is the observed value, minus the mean, which is 19.8, over the standard deviation, which is given to us as 2.4. Now let's see what is the value of p, or what is the value of the z-score that we are getting for this fraction. So I'll just open my CAIE and write 18.2 minus 19.8 divided by 2.4. It comes out to be negative 0.667. So negative 0.667. So that's the value of z-score that we have got if the probability of x less than 18.2 is what we are going to find. But now how do you find this? We find this with the help of the z table that we are having in the MF19 formula notebook, or I should say the normal distribution function table that is given to us. If you notice in this table, we must have the probability of z less than equal to the z value or less than z value. But in our case, the value of z is negative, if you notice. And in the booklet, the value of z starts from the positive value. It's not starting from the negative value. So there are two things I need to keep in mind, that my z must always be towards the right hand side of the zero line, because 0 is the mean for the standard normal distribution. My z will always be towards right of it because my z value in the table starts from positive value. And then the area that I'm going to shade is always going to be on the left hand side. If I'm having it on the right hand side, I can do 1 minus the probability of the z less than equal to the left hand side. That is how I can get it done. This is the kind of thing we have learned in the normal distribution. So in that case, what I can do over here is, first of all, I can use the property of symmetry to say that for this standard normal distribution, we have the mean exactly at 0, and this value of z comes to be slightly to the left hand side of the 0 line because it's negative 0.6667. So maybe somewhere over here, let's say, so negative z, and this is what we are supposed to find, and that will be the probability of z less than 0.667. But as I mentioned, that left side is good, but then there is a negative value of z. So according to the property of the symmetry of this distribution, I can say that if I had positive 0.667, so the positive value of z score, and then if I get the right hand side area, it is exactly same as what you are having on the purple side, the left side area. But now I cannot find the region on the right hand side. So according to the formula in the notebook, for the negative values of the z's, I can also do 1 minus the value of the z with respect to the positive value. And that is exactly what I'm trying to explain over here. So I can say that, I'll just scroll down. over here I'll mention this, that if I am having the value that I'm shading on the right hand side, it is same as writing 1 minus the area on the left hand side. So out of the 100% area, if I get rid of the left side part, I am left with the right side part. That is what is going to be displayed over here. So if this is the area you're looking for, you shade everything and then you just get rid of the left hand side. So from the everything, if you get rid of the left hand side, you get the right hand side area. And therefore straight away you can go ahead and say that this is equal to 1 minus probability of z less than 0.667. And now z is positive and even the less than sign is what we have got over here. Therefore this will be equal to 1 minus, over here if you look, 0.6, 6 and then 7. So 0.66 is going to give me 0.7454, to which I need to add 0.0023 at the end. And that is going to make me, let me open my calci. So 0.7454 plus 0.0023, and this comes out to be 0.7477. 0.7477. So this is this area, right? Now I need to do 1 minus this to get the right hand side part of the area. And therefore again I'll take out my calci and I'll do 1 minus answer. It comes out to be 0.2523. 0.2523. So that's the probability for the white pine tree having the height less than 18.2 meters. Now, because we want to find the expected value, I can say that therefore expected value will be equal to n into p, that is 450 into 0.2523. And the number that we are going to get is answer into 450. It is 113.5, which means I cannot have a half pine tree. So let's say it's going to be 113 pine trees. 113 will be the answer. White pine trees. So that becomes your final answer for the first part in question 4. Now for the second part, the heights in meters of red pine trees are normally distributed with the mean of 23.4 and the standard deviation of sigma, which is unknown. Now it is known that 26% of these red pine trees have height greater than 25.5 meters. We have to find the value of sigma. So what I'm going to do over here is, first of all, I'm going to draw the diagram of how these things are looking like. Or even before that, let me define a random variable y. This is the height of randomly selected red pine trees in meters. So now my y belongs to normal distribution. The mean is 23.4 and the variance is sigma square. It is also given that the probability of this y being greater than 25.5, the answer comes out to be 26% or 0.26. Now based on this, we are given to find the value of sigma. So over here, if I just try to draw a diagram, so I'm drawing the diagram not for z but for y. On the above scale, I was always drawing for the standard values z. Okay. Now I'm trying to draw for y, and therefore the mean value is not 0 but 23.4, and then 25.5 is towards the right of 23.4. So let's say somewhere over here. Let's say this is 25.5 and this area is 26% or 0.26. Now again, according to the MF19 data booklet that we are having, I am just having the data for the Z score being less than equal to the value of Z. So what can I do over here? It's exactly the same thing that we have learned in the previous part, that is 1 minus probability of y less than 25.5 will be equal to 0.26. This is just saying that out of 100%, if I'm getting rid of the left hand side, I'll be getting the right hand side. Simple as that. So I'm going to get, first of all, see, the reason over here that I've done this specific reason is 0.26. Okay. Obviously, the shading is towards the right, but the other reason is also 0.26. Now, 0.26 probability is not possible to find in this table because it starts from 0.5. The probability value starts from 0.5. So it is nowhere possible for me to go ahead and find this 0.26, and that is why I'm doing this conversion mainly because of this reason only. And then what I'm going to do is I'm going to replace these things as probability of y less than 25.5 is equal to 1 minus 0.26. So that comes out to be, I guess, 0.74. Let's just see, 0.26. So yeah, 0.74 is the answer. So the shaded region on the left hand side becomes 74%. So now I am in the less than category, and I am also having that area to be 74%. Now based on this, I can use my table to find out the value of sigma. How? I'll tell you. I know that therefore my value of z will come out to be the observed value minus the mean over sigma. So what is the value of z for my probability to be 0.74? So for this, I'll take my table, and where is 0.74? It is somewhere in between this value and this value. So let's see how much do I add from the right hand side digits to get 74. So I'm having 0.7389. So 0.7389, and then I need to add how much to get to 0.74. So minus 0.74 if I do, I'll be needing to have 11, 0.0011, right? So 11 is not possible to find over here, but I can do, oh wait, I am over here in between 10 and 13, right? Because 0.389 was over here. So I am in between this and this, which is 3 and 4. So I'm more towards 3, so I'll just keep it as 3 only. So the output that I'm going to get for the value of z for the probability 0.74 is going to become 0.643. 0.643 is what I'm going to get. So z is equal to 0.643. Okay, I'll just check it once more. 0.64 and then 3. Okay, great. And now I'll go back and state the value of sigma that I'll be getting over here as sigma will be equal to 25.5 minus 23.4 divided by 0.643, and this implies that my sigma value will come out to be 25.5 minus 23.4 divided by 0.643. It is 3.27. So 3.27 correct to 3 decimal places comes out to be a standard deviation, and that is the final answer that you're having for this part. Now for question 5, it is given that in a class of 21 students, there are 10 people playing violin, 6 people playing guitar, and 5 people playing piano. Now, a group of 7 is to be chosen from these 21 students in total, and then the group will consist of 4 people playing the violin, 2 people playing the guitar, and 1 playing the piano. In first part, we are asked to find in how many ways can the group of 7 be chosen. It's a straightforward question. So we are having to choose out of 10 people playing the violin, we need to have 4 people playing the violin. So I have to choose 4 from 10 multiplied by, for the 2 guitarists out of 6, I'll need to have 6 choose 2, and then lastly I'm having 5 pianists. From 5 I need to choose 1, so into 5C1. So let's see what is the answer that we get in the calci. 10C4 into 6C2 into 5C1. It comes out to be 15750. So 15750 are the ways in which the group of 7 can be chosen. So that will become our final answer for the first part of question 5. Now for the second part, on other occasion, a group of 5 will be chosen from the same 21 students. The group must contain at least 2 violinists. So I'll just make sure the conditions are written in front of me. So at least 2 people playing the violin, 1 playing the guitar, and guitar stands for G, and 1, and at most 1 pianist. So based on this, what are the different ways in which we can choose group of 5 people? So for this I can have this kind of combinations, that let's say I'm not talking about any single pianist and focusing on this at least 2 violinists and 1 guitarist. I can have this formation of 5 members as 1, 2, 3, 4. So I have 4 violinists, and then because 1 guitar is compulsory, the 5th one will be a guitarist. And then there are zero pianists. So that's one possibility. The other possibility is when I'm having 3 violinists and 2 guitarists. So the condition of having at least 2 violinists and 1 guitarist is still holding true. Now what about this thing? I can have 2 violinists and 3 guitarists, because if you can see, the total people playing the guitar is 6. So I can obviously take 3 of them in the group of 5, where the 2 violinists condition is still satisfied and 1 guitarist condition is also satisfied. Now I can go ahead with another possibility where I can have violinist, 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 at least 2, and then 1 guitarist, and at most 1 pianist. So I have this formation as well. And then the other formation that I can have is only 2 violinists, then 1 guitarist. I cannot have 2 pianists because at most I need to pick only 1 pianist. So I'll have 1 more guitarist and a pianist. Are there any different ways through which I can get these things done? No. So now based on this, let's form the combinations and then we can add them together. So for this, we are having 10 people playing the violin, out of which I need to choose 4. So 10C4 into 6C1 into how many people playing the piano? There are 5 people playing the piano. So 5C0. Then for this, I am having 10C3 into 6C2 into 5C0. Then for this, it is from 10 we have to choose 2, and from 6 we have to choose 3, from 5 we have to choose 0. And for this, we have to have 10C3 into 6C1 into 5C1. And lastly, this arrangement is going to become 10C2, then for the G, 6C2 and 5C1 for the P. Now I'm just going to add these values together, and I'm going to have my final verdict as total ways equal to, I'll take out my calci and have 10C4 into 6C1 into 5C0 Okay, it's going to take a lot of time for me to plug all of these things in my calculator, so I'll just fast forward this part for you. But I'll tell you what is the final answer that I'll be ending up with. Alright, so answer comes out to be 10,935 V's. 10,935. And then this becomes our final answer. And now for question 6. Teams of 15 runners took part in a charity run last Saturday. The times taken in minutes to complete the course by the runners from the Falcons and the runners from the Kites are shown in the table. We have to draw back-to-back stem and leaf diagram to represent this information with the Falcons on the left hand side. So we are going to keep the Falcons on the left, Kites on the right, and it's going to be something like this. Okay, as you can see that it's already arranged for us in the ascending format. We can see that it's starting from 3, both of them are starting from 3. One is ending up at 7 and the other one is ending up at 6. 3, 4, 5, 6, 7 is what I'll be taking in the middle part. And then on the left we are having Falcons, on the right we are having Kites. And then 3, 4, 5, 6, 7. Let's first fill the data for the Falcons. It is 8 and 9. So 8, 9. Then 4 it is 2, 4, 2, 4, 6, 8. 2, 4, 6, 8. Then for 5 it is 0, 1, 2, 6, 0, 1, 2, 6, 8, 9, 8, 9. And then 4, 9, 6. 4, 9, and the 6 is for the 7. Okay. For the Kites we are having 32 and 40, so 32, then 40, and again 40, then we are having 45, then 47, 48, then we are having 52, 54, 58, 59, 59, 60, 61, 63, and 65. So this is how we are going to get the stem and leaf diagram. And I'm also going to mention the key over here as, let's say for example, 240, 240 represents the time taken in minutes, right? So 24 minutes for Falcons and 40 minutes for Kites. So basically that is how you define your key and your stem and leaf diagram. Now based on this we can go ahead and give answer for part B, that is find the median and the interquartile range of the times for the Falcons only. So for the Falcons, if we have to find the median first of all, so according to me it's my choice. If it's already given to you in the ascending format, then finding the median from here directly is very easier for me as compared to using the stem and leaf diagram, but there is nothing hard for the stem and leaf diagram also. But yeah, I'll just continue with this table. So if I cut out this 38, 76, 39, 69, 42, 64, 44, 59, 60, 46, 58, 48, 56, 50 and 52. So the median value comes out to be 51. So I just mention it over here that the median is equal to 51 minutes for Falcon. Then interquartile range is given as the upper quartile minus the lower quartile. So how can you find the upper quartile? Upper quartile is the middle value from the right hand side of the mean. So for that, I'll cut 52, 76, 56, 69, 58, 64. So I'm left with 59. So my upper quartile is 59 minus the lower quartile. Lower quartile I can find in the same way from the lower block, that is to the left side of the middle value. So 38, 50, then 39, 48, 42, 46, left with 44. So if I do 59 minus 44 in my CAIE, even though it is straightforward, but I'll use my CAIE because why not? Answer comes out to be 15. So 15 becomes your interquartile range. And therefore, this is the final value of the interquartile range. And this is the median. I can also write minutes over here if I write. And that's it. I'll also say that for the above part, this is your answer. Now for part C, it is given that let X and Y denote the times in minutes of a runner from the falcons and the runners from the kites respectively. So X is for the falcons, Y is for the kites. It is given that the summation of X value is 792. Summation of X square is given to us as this. Summation of Y is this. Summation of Y square is this. We have to find the mean and the standard deviation of the time taken by all the 30 runners. 15 from the X, 15 from the Y. So based on this, what I can do is to find mean of X and Y, the total time taken will be the summation of X plus summation of Y, and because there are 30 participants, I'll need to divide this by 30. And then if I calculate this in my calculator, it's going to become summation of X is 792, summation of Y is 783, and then that is divided by 30, and the answer comes out to be 52.5 minutes. So that is the mean that we are getting for all the 30 runners. And then the other thing we are going to do is to find the standard deviation. Now, which formula you can use? We can go ahead and use the formula booklet to understand this. So from the given definitions of the standard deviation, I can go ahead and use this particular formula that is given to us, that is square root of summation of x square plus summation of y square over the 30 minus the mean value that we have just obtained. And therefore, I can say that, oops, I'll change my color. So it's going to become standard deviation of x and y together will be equal to square root of summation of x square plus summation of y square divided by the total n 30 minus the mean square, which is 52.5 square. So square root of ex square comes out to be 43,504 plus 42,223 divided by 30 minus the mean square, which is 52.5 square. And this value is 10.1, correct to 3 significant figures. And therefore, you are done with your part C as well. Now for question 7. In a game, players attempt to score a goal by kicking a ball into a net. The probability that Leno scores a goal is 0.4 on any attempt, and is completely independent of all the other attempts made by Leno. Now, the random variable x denotes the number of attempts that it takes Leno to score a goal. And in the first part, we are asked to find the probability that Leno took 5 attempts to score his goal. So because there are no fixed number of trials in this question, we can say that we solve this question with the help of geometric distribution. And therefore, we can say that because there are 5 attempts that was taken by Leno to score a goal, the first 4 attempts were failure. So if the probability of success is 0.4, the probability of the failure will be 1 minus 0.4, which is 0.6. So for 4 failures and then the success, that will be our formula according to the geometric distribution. And if I solve this using my CAIE, I'll be getting 0.6 power of 4 into 0.4, and the answer is 0.0518. And that is my first answer for question 7. In the second part, we are asked to find the probability that Leno took either 3 attempts or 4 or 5 or 6 or 7 attempts. What is the probability of all of this? So I can state that this is simply probability of x is equal to 3 or 4 or 5 or 6 or 7, and this is equal to, if I was taking 3 attempts to score a goal, that means there are 2 failures and then a goal. Over here, there are 3 failures and then a goal. Over here, 4 failures then a goal, 5 failures then a goal, and over here, 6 failures then a goal. So for sure, there is one goal, and therefore, because of that, 0.4 is a constant, which will be multiplied by, first of all, 0.6 square. 0.6 square denotes 2 failures and then the goal. So that is probability of x3. Then 0.6 power of 3 denotes 3 failures then a goal for the 4th attempt. Then 0.6 to the power of 4 will be the 4 failures and 5th one is the goal. And similarly 0.6 power of 5 plus 0.6 power of 6. And if I can solve this in my CAIE, 0.4 into summation of 0.6, oops, this is not the summation, this is summation, 0.6 to the power of x, where the x value goes from 2 to 6. And this gives me the answer of 0.332. So 0.332 will be my final answer, and I'll erase this kind of 2, 3, 4, 5, 6 that I've written over here so that it looks neat. And finally, I'll change my color to mark my final answer. For part C, it is given that find the probability that Leno scores his second goal on or before his 5th attempt. So on the 5th attempt or all the previous attempts, whatever is the attempt that we are looking forward to up till 5th attempt, the last attempt will always be a goal. That is the second goal. And before that, I can score goal in any of the previous attempts. So for example, if I have to explain this, for 2 attempts, if the second attempt was my second goal, then it basically means in the first attempt, I must have a goal so that on the second attempt, I'm having my second goal. Then for, let's say, scoring the second goal in the third attempt, I am having 2 places to score either of my first goal, and then the second goal is on the third attempt. So I can arrange my G and F. If one is goal, then obviously the other is failure. So I can arrange this G and F in 2 factorial ways, right? And then that 2 factorial ways is going to be multiplied with the probability that Leno scores the second goal on the third attempt. Then similarly, I'm having my 4th attempt. In that, I'll be having 3 different empty spaces in which I can have my first goal and 2 failures. But then because there are 2 Fs, I'll need to have 3 factorial for the 3 possibility of the arrangements divided by the 2 factorial because of the 2 Fs. And then the 4th attempt will be a goal. Okay. And then in the 5th attempt, very similar to this, there will be 1, 2, 3, 4 different ways in which I can have my first goal. So 4 factorial divided by 3f, so 3 factorial, and then the 5th attempt will be a second goal for the Leno. So the calculation will be as follows. If on the second attempt Leno was scoring his second goal, we will have 0.4 square. Then for this we'll have, there are 2 success and 1 failure. So 1 failure is multiplied with 2 success, but then in 2 factorial ways. Over here we are having 2 success, 2 failures. So 0.6 square multiplied by 0.4 square. Now I'm having 3 factorial ways to arrange this, divided by 2 factorial because of the 2 f's. And similarly in the last one, there are 3 failures, 2 success, and this is 4 factorial by 3 factorial because of 3 f's. So based on this, I can go ahead and use my CAIE and simply add these things to get the final value of the probability. And that is going to be, this implies that the probability that Leno scores his second goal on or before fifth attempt will be equal to, then the value that I'm getting over here is 0.663. So 0.663 comes out to be my final answer for this part. And now for the last part, it is given that Leno has 75 attempts to score a goal. So now we are having fixed number of trials. Using a suitable approximation to find the probability that Leno scores more than 28 goals but fewer than 35 goals. So because we are having fixed trials now, that is 75, we can say that we can approximate our binomial distribution as our normal distribution. So first of all, I can say that my x is random variable such that Leno, the number of attempts to score a goal by Leno. Lenovo. Oh, okay, never mind. And from here we can say that x belongs to the binomial distribution with n being 75, and what else is given to us? 0.4 is the probability of scoring a goal on an attempt. So 0.4 will be the value of P. Now we can go ahead and convert this into the normal distribution if the NP and NQ value is greater than 5. So for that, I'll go ahead and check what is the value of NP coming to be. For that, I'll take out my calci. So I'll say that 75 into 0.4, it is 30, which is greater than 5. Then NQ, 75 into 0.6 comes out to be 45. And then NPQ, 75 into 0.4 into 0.6 comes out to be 18. So NPQ is what I'll write over here. So NPQ is coming out to be 18. So now I can say that my X will now follow the normal distribution because I'm approximating this, or because X is the random variable in the discrete format, I can say that now my Y will approximately follow the normal distribution will with the mean of 30 and the variance of 18, because NPQ is the variance and NP is the mean. Now from this we can continue ahead. So I have to find the value for which my Y is between 28 and 35, and both of them are exclusive, more than 28 and less than 35. So it is not equal to 28 or equal to 35. So this is what we have to find. Now, because we are approximating the binomial as the normal distribution, so we are going from discrete variable into a continuous variable. And that is why I'll need to have the continuity correction to account for this change. So what really happens over here is, if I'm going to draw a quick curve for my normal distribution, something like this, let's just assume that 28 is over here and 35 is, let's say, somewhere over here. It could be literally anywhere towards the right of 28, it does not really matter. Now to make it into a continuous format, we add plus minus 0.5. So I can say that this is 27.5, this is 28.5, and this is 34.5, and this is 35.5. Now If it is less than 28, so I'll need to take 28.5 into consideration because 28 is not included. If 28 was included, I would have used 27.5 because 28 was supposed to be counted. But because both the cases 28 and 35 is not to be included, I'll go from 28.5 to 34.5, because even if I go for 35.5, 35 will be included. So in that case, this is the range that I'll need to have for my y for the continuity correction. And therefore, after continuity correction, we have to find probability of y in between 28.5 and 34.5. So this is same as writing probability of y less than 34.5 minus probability of y less than 28.5. Please excuse the WhatsApp notification. So let me just turn them off very quickly. Just a second. Okay, I've turned them off, and coming back to this. Now I can find the Z score for both of this and solve this using the table. I'll also need to open the table. I just closed it by mistake. Just a second. Yeah, there we go. Open with Adobe. And yeah, there we are having the formula booklet. Okay. So to find out the value of Z, I know the process is very simple. 34.5 minus 30 divided by square root of 18. 34.5 minus 30 divided by square root of 18 minus probability of Z less than 28.5 minus 30 over square root of 18. Then this will give me, let me take out my calci. So 34.5 minus 30 over square root of 18, that comes out to be 1.061. 1.061. 1.061. And similarly, the other value of Z that I'll be getting will be negative. But let's calculate 28.5 minus 30 and divided by square root of 18. That gives us negative 0.3536. Negative 0.3536. Now, based on the previous questions that we have solved, I can clearly see that I can find this value very easily from the table Z less than 1.061. And for this is same as writing 1 minus probability of Z less than 0.3536 or 0.354, whatever it is. Okay, I'll just do one thing. I'll open my calci and recalculate this, or else I guess I'm fine. I need to say that this is 0.354. The reason I'm doing this is because if you look into the table, okay, I'll need to scroll down. In the table, you are having 0.1, 2, and 3 decimal places only. So over here, I'll need to have 3 decimal places only. So that is what I was ensuring that it is correct. And therefore, the final equation that I'll be having over here would be P of Z less than 1.061 minus P of Z, not minus, but minus minus becomes plus. So Z less than 0.354 and then minus 1. Now let's use my table to find the probabilities for the following values of the Z. So 1.061 is what I'm looking for. 1.0, then 6 and 1. That makes it 0.855, and then two decimals. I'm going to add 2 to the last decimal. So 0.8556 is what I'll be having. 0.8556. 0.8556 plus then probability of Z less than equal to, less than 0.354. So if we see, we are having 0.3, then 5, and at 4 we have to add 15. So 0.6368 plus 0.0015. So if I do this in my calci, 0.6368 plus this 15 because of the 4, 0.0015, it gives me 0.6383. 0.6383 and then minus 1. Let's have our final answer. So it is going to be this plus 0.8556 minus 1, and that comes out to be 0.494. So that's it. That is how you solve this question. Just note that this conversion was something that I've already explained, so I did not really re-explain the same concept, but you can get the same kind of information over here. If you're having negative z value, it is same as writing 1 minus positive z value, and that is what we have implemented over here. And that's it about this paper over here. I hope all the questions, the solutions that I've given for them are crystal clear to you. In case of any doubts, you can leave them in the comments. And don't forget to leave a like, subscribe, and also share it with your friends who are appearing for the upcoming 2025 session examinations. Thank you so much.